Hi there, welcome to a latest edition of our homework, and today we're going to be looking at alkanes, a family of hydrocarbons. We're going to be looking at the naming of alkanes, we're going to be looking at how we can work out the formula of an alkane, and then we're going to be looking at the structure of an alkane. Anyway, I hope you enjoy this. Okay, so our objectives for today's lesson on alkanes is by the end of this lesson you should know and understand how to describe the structure and formula of the family of hydrocarbons called the alkanes. Okay, now the alkanes, they follow a fairly simple way of naming. They have two parts to the word. They have the prefix, which is always an alk. And we'll talk about those in a moment, but for every alkane, the end of it is ane. Okay, now the first four are a little bit unusual, okay, within the family. Okay, these are called methane, ethane, propane, and butane. Now, after the first four, the next few are relatively straightforward. For 5, it is pentane. For 6, it is hexane. 7, heptane. 8, octane, nonane, and decane for 9 and 10. Okay, and that just follows the same as what you will have done in maths about sided shapes. So a decagon has 10 sides. Anyway, there we go. Now with the formulae follow a quite complex mathematical pattern. Okay, this is what we call the general formula. Okay, now because it's a hydrocarbon, it's got carbon atoms and it's got hydrogen atoms. Okay, now this here is n, which you may know from maths can be any number. Now whatever the number of carbons is, there will be twice that value plus 2. So if we take a simple example of ethane, which has 2 carbons, 2 times 2 is 4, plus 2 is 6. So this gives us a formula of C2H6. So if we look at another one, if we look at pentane, we've got C5. Okay, so 2 times 5 is 10, plus 2, which gives us 12. Okay, so just using this formula here, we can work out any formula of any alkane. Right, now the structure of alkanes is very, very simple. It follows that the carbon must have 4 bonds attached to it. So if we take our first example here, methane, now this is a 3D drawing where this one is coming out of the page and that one is going into the page or away from the page, and then this one is on. These two are on the page. Okay, now we can see the central carbon there has 1, 2, 3, 4 bonds. Okay, so from the previous one where we looked at methane, it has 1 carbon, and then 2 times 1 is 2, plus 2 gives us our 4 bonds or 4 hydrogens. Okay, now the next one we'll look at, ethane. Okay, now this is just a straightforward model. We've got the 2 carbons. Okay, and then they've got the 1, 2, 3, 4 bonds, and this one 1, 2, 3, 4 bonds. Now sometimes you may see models that are what we call ball and stick diagrams, where we've got the carbons here in the chain. Okay, so we've got 1, 2, 3, 4, which is butane, and then we've got the 2 times 4 is 8, plus 2 is 10, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 hydrogens on there. Okay, so this is the possible structures you may see for the alkanes. So if we review what we've done today, we've looked at the naming of the alkanes. If you can remember that they always have an "ane" at the end. Okay, the first four are a little bit more complicated than the rest of them. We looked at the formulae of the CnH2n plus 2, and then we've looked at the structures of them where each carbon must have 4 bonds attached to it. And then the hydrogens only have 1 bond, so they just attach themselves to the carbon. Anyway, I hope you've enjoyed this, and I will see you next time. Bye.